So what they did here is they wanted to find the antiderivative of the 6 trigonometric functions. Well, sine and cosine are easy enough. The integral of sine is negative cosine of u, and the integral of cosine would be positive sine of u. Okay. Tangent we did together. That was the negative natural log of cosine of u. We also did secant together. That was natural log of secant of u plus tangent of u. Okay. So very, very similar proofs for cotangent of u and cosecant of u. Very, very similar techniques. So with cotangent, you would let it be cosine over sine, and then you would let u be the denominator, which is sine. And for cosecant, instead of multiplying it by secant plus tangent, you would multiply it times cosecant plus cotangent on the top and bottom. So that's how you'd prove those two problems right there. Really, really cool problems for you to see. Okay? So let's finish up by doing a couple more problems here. What we want to do is find some definite integrals using these trigonometric functions, or transcendental functions is what the book calls them. So let's see if we could do this one right here. Example 10 says evaluate from 0 to pi over 4 of the square root of 1 plus tangent squared of x dx. So what's the key here? The key here, the trick is to realize that secant squared x from the Pythagorean identities, I don't know if you remember the Pythagorean identities, it was sine squared x plus cosine squared x equals 1, right? And then if you divided everything by cosine of x, so if I divide everything by cosine squared of x is what I meant to say, you would have that tangent squared of x plus 1 equals secant squared of x. So that's our Pythagorean identity. So instead of 1 plus tangent of x, we're actually going to plug that in as secant squared of x. Oops, sorry, let me use my highlighter. So they're getting that from the Pythagorean identity, sine squared plus cosine squared equals 1. So what's this the same thing as? This is the same thing as the integral from 0 to pi over 4 of the square root of, instead of 1 plus tangent squared of x, we just said that that's secant squared of x with respect to x. Well, the square root of a square is just simply the original function. So this is going to be the integral from 0 to pi over 4 of secant of x dx. That's one of the integrals that we just did, right? So this is one of the integrals we just did. This is equal to the natural log of the absolute value of secant x plus tangent of x. And this is evaluated from 0 to pi over 4. And again, here's what I'm just going to write a little note. Just did this. And it's in the list of those rules above. So if you want to use those rules above, that's perfectly fine. Again, if I just asked you what's the integral of tangent of x, you can't just give me the answer. You can't just use those rules stated above. You'd actually have to show that work. But in here, it's only one part of it, so it'd actually be okay if you use the rule on this one right here. So what is this going to be equal to? Well, if we evaluate it, let me go back to black here. If we evaluate it, it would be the natural log of, well, this would be the secant of pi over 4 plus the tangent of pi over 4 minus the natural log of the secant of 0 minus the tangent of 0. Okay, and that's absolute value there. Sorry for that. So let's think about this. What is secant of pi over 4? So that'd be cosine of 1 over cosine of pi over 4. So that's 1 over root 2 over 2, which is 2 over root 2, which is 2 root 2 over 2, which is simply root 2. Just put the dang thing in your calculator if you don't know that. So this right here, this value right here is a square root of 2. What's tangent of pi over 4? Put that into your calculator if you don't know it as well. That's a 1. What's secant of 0? Secant of 0 is 1 over cosine of 0. Well, cosine of 0 is 1, so this would be 1 over 1, which is 1. And then tangent of 0 is sine of 0 over cosine of 0. So that would be a 0 over a 1, so this would be a 0. So what I'm ending up with is the natural log of the absolute value of square root of 2 plus 1 minus the natural log of, well, 1 minus 0 is just 1. And the natural log of 1 is just 0. So that turns out to be the natural log of the absolute value of square root of 2 plus 1, whatever the heck that is. In the book they use a decimal approximation. I'm fine with you using the actual answer here. So I'm going to say the natural log of the absolute value of the square root of 2 plus 1, whatever the heck that value is. Okay? So, cool little trigonometric substitution there, knowing your Pythagorean identities. Again, we reviewed this in the trigonometry review at the beginning of the semester. All right, let's look at the next one. Great problem for us to do because it says find the average value of this function on the interval. If you remember, to find the average value of something, it's 1 over b minus a times the integral from a to b of that function with respect to x. So that's how we have to set this up to find an average value. So in this case, it's going to be 1 over pi over 4 minus 0 times the integral from 0 to pi over 4 of tangent of x dx. Okay, so that's 1 over pi over 4. 1 over pi over 4 is the same thing as 4 over pi if you invert, right? So that'd be 4 over pi times the integral from 0 to pi over 4 of tangent of x dx. But we know what this is equal to, the integral of tangent of x dx. So I'm just going to say see previous problem, because we did this. This is in the rules above, right? So this would be equal to 4 over pi times the integral of tangent of x was negative the natural log of the absolute value of the cosine of x. That's what we proved on the previous page, right? And this is going to be evaluated from 0 to pi over 4. Holy cow. So let's see what this is equal to. So this would be equal to 4 over pi times, well, I'm going to pull that negative out in front as well. So this would be the natural log of the absolute value of cosine of pi over 4 minus the natural log of the absolute value of cosine of 0. So let's think about that. Cosine of pi over 4 is root 2 over 2. Cosine of 0 is 1. And a natural log of 1 is a 0. So it looks to me like I'm getting negative 4 over pi, don't forget that constant multiple, times the natural log of the absolute value, but it's already positive, so that doesn't really matter, of root 2 over 2. Whatever the heck that is, I could plug that into my calculator to get a decimal approximation, but that's not what the book asked for. That is what the book does. It gives you both this answer and the decimal approximation. I would leave it as an exact answer unless the actual question asked you to round it or use a decimal approximation. So that's the exact value right there. Hope that makes sense for you.